Well, the first thing we found is that consumers save $2.7 trillion by the year 2050. That translates to an average household savings of about $1,000 every year. And that's excluding environmental benefits and public health savings. This is just because EVs are cheaper to own and they are cheaper to maintain and operate.
Welcome everyone in person and online to the PWS seminar this week. Really excited to see such a big audience today. Not a surprise given who our guest speaker is, the one and only Sara Baldwin. She's joining us online, and I'll pass the screen share over to her. But because this is such an important topic, we wanted to make sure that everyone could ask questions and also that we could rank the questions to make sure we use the time effectively. So we're going to use this Slido app. You can either look at the QR code or just go to sli.do and type in code 424242. So if you have any questions, either clarifying questions during the presentation or questions that you want to discuss afterwards, enter them there. I'll see them and then we'll make sure that Sara will get those at the end. Yeah, you get to choose your code. And of course, I picked an awesome one, right? I'm going to give, just while you're pulling up that Q&A interface, I want to give an introduction to Sara. She is the Electrification Policy Director of Energy Innovation. This is a nonpartisan energy and climate policy think tank. It has a peer-reviewed energy policy scenario tool. So you can say, hey, were we to introduce different changes in policy, here's how it would affect prices and carbon emissions, all kinds of other really cool things based on the actual science. It also has an excellent climate policy book, and there's an amazing podcast that is hosted by Sara herself called Electrify This. So I encourage you, if you do nothing else, sign up for that podcast on whatever platform you like, and it's a great place to get started. Now, Sara has a really rich and diverse background. She's contributed to dozens of both peer-reviewed and public-facing reports and papers, including serving on Grid Lab's advisory board. Grid Lab is an awesome resource if you want to get down into the nitty-gritty of how to clean up our whole economy. She earned a Bachelor of Science in Environmental Studies and a Bachelor of Arts in Spanish from the University of Utah, so not too far away, graduating with honors. And from 2004 to 2014, she directed and implemented strategic clean energy policy and regulatory efforts in Utah as a senior policy associate for Utah Clean Energy, really interesting and creative group. She was named Innovator and Influencer by Solar Power World in 2017, and one of Utah's Enlightened 50 by the Community Foundation of Utah in 2012. So after that, she was recruited by the Interstate Renewable Energy Council, IREC or RIEC, as their Vice President of Regulatory. And she worked with states across the country to develop strategic plans and implement those plans to clean up energy supply and deal with climate change. She also served on the technical team for the U.S. Department of Energy's Sunshot Solar Market Pathways Initiative and the National Renewable Energy Laboratory's Distributed Generation Interconnection Collaborative Advisory Committee. So again, NREL is the premium group that's doing research in this area. So for those of you who came in afterwards, here's the Q&A. Slido 424242. And with that, why don't we give Sara a round of applause while I switch over to her.
Awesome. Thank you so much, Ben. What a kind introduction, and really thrilled to be with you all here virtually. I'm sorry I'm not there in person, but really glad that we have the technology and the capabilities to do this hybrid model. I think it's pretty awesome that we've adapted to allow for this. So with that, I'm going to share my screen and dive in. I have quite a bit to cover today and really looking forward to your questions and the conversation. And I can start. Okay, are you all seeing the main title screen?
Yep, we see that perfectly.
Okay, great. So I'm going to go ahead and dive in. Ben provided a great introduction of my professional background, but I want to share a bit more about who I am as a person, not just as a professional. I was born in Utah. I was raised in Missouri, but I came back in the year 2000 to go to school, something about that mountain view, you just can't get that in Missouri. So I had to return to my roots. My grandparents were born in Milford, Utah and Beaver, Utah. I didn't know, of course, when I started down the path of this clean energy career, that I would help get Utah's first wind farm installed in Milford, Utah. But that was a really cool connection for me personally to say, like, yeah, my grandpa grew up here and now the largest wind farm in Utah is located here, and, you know, really had a huge impact on economic revitalization for that very remote rural area of Utah. I also helped get the first Wind for Schools project in Utah installed down at the Milford Elementary. And that's that picture up in the right-hand corner there. And over the course of my time working with Utah Clean Energy, I spent a lot of time lobbying the Utah legislature, you know, trying to convince our state leaders and county and city leaders that clean energy is really the future. In spite of our very rich fossil fuel history, there are opportunities for us to tackle some of the biggest challenges of our time with clean energy. I also helped do really cool stuff throughout the 10 years I was with Utah Clean Energy, like launch the first community solar program. It was kind of a group on, group buy program for solar. And that really did a ton to get more solar installed on roofs across the county and city. And the list goes on, but ultimately, Utah's my home and I love it. And I want to make it a better place going forward. All right, so here we are today, talking about some serious stuff and some exciting opportunities on the horizon. So first and foremost, climate change is real and it is happening now. If there's nothing else that you take away from this presentation, let it be that. And hopefully this is a message that you can share with people in your lives, because it is not something that we should be debating any further. We know from extensive studies, 97% of scientists across the world agree that this is happening. And scientists have known for some time. I mean, this is not a new phenomenon. We've actually had data and reports going back to the 70s and 60s, and from multiple lines of evidence, as quoted here by the US National Academy of Sciences, humans are changing the Earth's climate, primarily through greenhouse gas emissions. Now, let's see here. There we go. Oh, does that look really weird for you guys? Okay, I don't know what happened there. Secondly, our dirty air is really bad for us, and it is really getting worse. Consistently, the American Lung Association ranks Salt Lake City among other cities across Utah in the top tier for worst air quality. And we consistently get Fs on report cards. I'll show that in just a minute. And the kind of scary part about our air pollution is that climate change exacerbates our air pollution issues, because we have what's called a positive feedback loop. We have hotter conditions that create more smog. We have drier conditions that can cause more particulate matter pollution. We have more fires, we have more dust storms, so on and so forth. It's really quite a vicious cycle. So, you know, the thing that really motivates me as a person who lives here is air quality, in addition to climate being like the biggest crisis that we have on our hands today as humans. But, you know, I breathe this air day in, day out, and I'd like to breathe a little cleaner going forward. So I'm very motivated on that front. Oops, excuse me. As I mentioned, the American Lung Association does a State of the Air report every year. You can get it on lung.org. And they rank every state and every county in the country based on particulate matter and ozone, the two biggest contributors to poor air, and number of orange days and red days and purple days. And as you can see here, for both ozone and particulate matter, we have a number of counties that are F or D on an annual basis, including where you all are, Utah County, where I am, Salt Lake County, but even places that you don't think about as being like really poor air, but like, you know, Duchesne County has a ton of methane emissions from oil and gas operations that contribute to really bad ozone. And, you know, all along the Wasatch Front, basically where we have population, we have poor air. And I promise I'm going to get to solutions. This is not all doom and gloom. The other thing to keep in mind, and something that's actually kind of relatively new in terms of our understanding, is that combustion of fossil fuels indoors is also bad for us. If any of you are campers and you have those little portable camper stoves, they all have big warnings. Do not use this in a closed airspace. The reason for that is the burning of whether it's gas or propane releases a number of harmful emissions, many of them that are greater, like at levels greater than what we see sometimes in our outdoor air. And gas stoves are one of the leading contributors to poor indoor air quality. And they found that children that grow up in homes with gas stoves, especially those that are poorly ventilated, have a 42% chance of getting asthma. So that's a pretty alarming statistic, excuse me. And I think, you know, for me personally, I have a gas stove in my home. It does not have a vent. And I have since bought an induction cooktop, just a portable one in the interim. And I use that for 99% of my cooking. And I no longer get headaches when I cook. So I know for a fact that it's actually a real thing. So with all of that, I'm going to talk about the climate piece and the pathways to decarbonizing our economy. And the other thing to just keep in mind, again, circling back to this connection between air quality and climate, that so many of the solutions that we can go forward with quickly to address our climate challenge can help our air quality challenges. So they go hand in hand, one and the same. Quick snapshot of our economy. It's a little dated just because that's how the EPA works with their retroactive look at data sets that come in. But right now, our electricity grid, industry, transportation, and commercial and residential buildings are the vast majority of our greenhouse gas emissions, and agriculture contributes about 10%. And they're about thirds for transportation, industry, and electricity. Buildings are a smaller subset. Okay, so bear with me on this slide. I will explain it. There's a lot going on here. So as Ben mentioned, the Energy Policy Simulator is a tool that Energy Innovation created. It is a publicly available model. You can go on our website and play around with it. It's a really cool tool, especially if you like charts and graphs, which I do. I did not create the model. This is definitely done before my time with Energy Innovation. And we're constantly updating it based on new data sets, based on new understandings of policy metrics to figure out how we reduce our greenhouse gas emissions. So I'm going to walk you through this just a little bit to explain it. So up here on this line, we have our kind of business as usual trajectory for our greenhouse gas emissions. And this big line down here is what's called the 1.5 degree scenario. This is what we need to be doing as a country to align ourselves with a climate stable future to limit warming to only 1.5 degrees Celsius. And these wedges that you see filling in this large space between represent the core sectors of our economy. So up here you have land use and agriculture, green is buildings and appliances, purple, transportation and mobility, blue, electricity grid, red, industrial sector. And so what the Energy Policy Simulator model does is it very meticulously evaluates each policy lever and figures out which one's going to get us the biggest wedge. You can come up with all different iterations of this graph, depending on how you tweak the model and how you play with the tool. But effectively, it aims for the most cost-effective and the most scaled emissions reductions as possible. So, you know, there are literally infinite ways we could tackle our climate problem. But the problem that we have is that we don't have infinite time. We have literally a decade right now. The next decade is going to be the most critical to drive down emissions severely enough that we can reach this end state of 2050. And of course, the other component to all of this is you have a lot of embedded carbon already in the atmosphere. That's going to stay. No matter what we change today, everything that's been emitted already is going to persist for decades. And so it's really critical that we start to focus on which policies can get us there the quickest and the cheapest and the most efficient. Now, I'm not going to go through each of these, but I am going to talk about the three sectors that probably are the most relatable in terms of you all, as well as every human lives in a home, goes to buildings to work and or go to school. You drive something or get around somehow, and we all use electricity. So that's what I'm going to focus on today. Now, as noted, my title is Electrification Policy Director. So electrification is effectively shifting the existing fossil fuel uses that we have in our transportation, buildings, and industrial sectors to use clean electricity instead of fossil fuels. So the electricity grid has a lot of low carbon options: solar, wind, geothermal, nuclear, hydroelectric. We can get a low carbon grid with the resources and technologies we have today. We don't really have viable alternatives for transportation, for buildings, for industry, other than shifting to electricity. So this has been vetted by hundreds of people at this point. Electrification is the fastest way to decarbonize our entire economy and to get there quickly, efficiently, without compromising our quality of life. So the little lightning bolts that I put here are indicative of the policy wedges that represent electrification for each of the sectors. Now, I am not going to talk about industry today. There's a lot there. It's quite a deep dive. Happy to at some point in the future, if that's of interest, we can circle back on that. But there's a ton that can be done to industry to decarbonize, including through electrification. Okay, diving into the clean grid. So my organization did a series of reports earlier this year, and this one, known as the 2030 report, evaluates the feasibility and the techno-economic impacts of achieving an 80% clean grid by 2030. And the reason it's 80% is it's sort of like we can get to 80% in the next 10 years. We may not be able to get to 100% in the next 10 years, but we can definitely do 80%. So what does that look like, and how does that impact things? As noted, Grid Lab was one of our partners, and we had also some excellent researchers with the University of California, Berkeley, Goldman School of Public Policy. So underpinning this analysis is really the kind of the awesome reality that our cost for renewable energy has come down drastically over the last several years. Solar used to be really expensive, batteries used to be really expensive, wind really expensive, and all the forecasts basically, as shown here in these lines, all these forecasts, whether they were high, low, or medium, we've far exceeded them by now. So this is where we are today, and these were the forecasts just a few years ago. So we're basically beating the forecasts. Cost declines are consistent and enduring over the last several years. This little blip that you see here is when the PTC, the production tax credit for wind, expired, and that caused an increase in overall costs for wind. But we're back on track to continue to see declines in those costs. So evaluating an 80% clean scenario next to a no new policy scenario, what does that look like in terms of our grid makeup? Well, as you can see, nuclear stays the same. We're basically hoping to keep the existing nuclear fleet online because it's carbon-free energy and it's still working. So, and we've paid for it, and it's long-lasting energy source. So it remains about the same. Coal comes down pretty drastically towards the end of the decade. Gas stays about the same. We don't actually build new gas in this 80% clean scenario. We keep the existing gas fleet mostly online with some retirements, and that is to balance the grid and have some on hand for really, really peak times when we know we're going to need to ramp up quickly. Existing hydro stays online just the same. This green line is like geothermal, some petroleum, some random stuff. Again, kind of stays the same overall in terms of total quantity. And then we see a big ramp in wind, solar. What's not shown here is an additional ramp with battery storage coming in to fill in the gaps that solar and wind may have at any point in time. What this model found and what the researchers out of Berkeley found is that the grid is actually very dependable without coal or gas. Now, I did not run these models. I cannot speak to the all the assumptions and methodology, but I can speak to the fact that these folks have been doing this for quite a long time. They're associated with the Lawrence Berkeley National Lab, super smart guys. Dive into the report if you want to learn more about this. But effectively, our load is shown here in this black line. And it ebbs and flows as we go to sleep and come back online and so on and so forth. And they looked at this, not just one day of the year, but they had like a 7-year weather forecast or historical forecast of weather. They matched it with real-time load data and real-time hourly dispatch across different sectors of the power grid. So this is very representative of kind of the average scenario. And what this shows is basically we have batteries that are operating down here during these kind of gaps. We have nuclear, as I said, kind of staying online. We have our gas is going up and down to meet different weather fluctuations. Our solar and our wind are doing what solar and wind do, typically daytime solar, nighttime wind. And curtailment basically is like when we have too much of this stuff, we oddly turn it off so it doesn't break the grid. But demand response and demand flexibility could be a resource to deploy in order to like take advantage of the excess resources. And so basically what this shows is that we're meeting load on an hourly basis, and we're not breaking the grid, and it remains reliable. We do have to build quite a lot of solar, wind, and batteries. This shows the trajectory of growth in terms of capacity additions in gigawatts between now and 2030. Close to 1,200 gigawatts needs to be built. Now, the good news of achieving an 80% clean grid is that we drastically drop our emissions in the decade. We drastically reduce air pollution, both SOx and NOx, and we improve our public health and avoid a ton of premature deaths, 93,000 avoided by the year 2050. So this is good news, I think. We also found that the electricity costs were actually lower than they are today. This is the 80% clean scenario. And it's basically because renewables are so cheap and only expected to get cheaper that, and they're not subject to fuel volatility, that we can see and count on a reduced cost to consumers. Okay, there's a lot more to talk about with respect to that study and the clean grid, but moving forward and in light of time, I want to keep us on the trajectory. So next, we actually have a great study looking at transportation. Along similar lines, our industry projections of battery prices have been wrong in a good way, in that battery prices continue to get lower and lower. So right now we're about here. This was one of the most recent Bloomberg New Energy Finance projections. This is where Tesla is. This is where a China company is. This is where Tesla's expecting to be. This is where GM's expecting to be. And when we modeled it, this was our projection, just sort of a kind of average of some of the more extreme reductions and where we were a few years ago in our projections. So this study is the 2035 report 2.0, in that it builds on the 2035 and 2030 reports looking at just the clean grid, and then we layer on transportation electrification. So we modeled what it would look like in a drive clean scenario, which basically translates to percentage of cars and trucks that are new being sold in the market and how much of them are electric. So in this case, the drive clean scenario, we have 100% light duty vehicle sales by the year 2030. We have 100% medium and heavy duty vehicle sales as electric vehicles by the year 2035. So this is a very ambitious trajectory. But again, the question was, what happens if we do this? And how does it compare to a no new policy scenario, which, as you can see in these other sectors, really lackluster in terms of how many EVs are deployed. Well, the first thing we found is that consumers save $2.7 trillion by the year 2050. That translates to an average household savings of about $1,000 every year. And that's excluding environmental benefits and public health savings. This is just because EVs are cheaper to own and they are cheaper to maintain and operate. Consumer Reports did a similar study, and they found that on average, EV owners could expect to save $4,000 just in fuel savings alone, and a total cost of ownership savings of between $6,000 and $10,000. So, and I can attest, I've been an EV driver for a few years, and it is a very cost-effective proposition. And you just almost forget about the gas station. You're just like, oh yeah, somebody has to fill up a gas tank. I sure don't. So it's a ripe opportunity to help consumers put more money in their pocketbooks. And what a great time given what gas prices are doing right now. Now, we also found the grid impacts were modest. If we really ramp up electrification of transportation and we layer on some building electrification, which I'll talk about, and industrial electrification with and in this case, we modeled a 90% clean grid in the year 2035, all of that combined, still reliable, still able to meet hourly load, still able to provide affordable, cost-effective energy for all people. Also, by comparison, our demand grew around 2.6 per year between the years 1975 and 2005 during a high growth period in our economy. And we anticipate that this growth represents around 2 to 3% per year as well. So takeaway is we've done this before. We've built up our grid very quickly. We've accomplished rapid build out of both distribution and transmission systems and capacity additions, and we can do it again, just in a different way than we have in the past. And then, of course, we have investments in public charging infrastructure that will be needed on top of grid infrastructure, and I'll talk about that in just a second. But again, because the reduced costs of renewables serving the vast majority of this load, we do not see an increase in today's costs on either the wholesale transmission side or the distribution side. So what does it look like to have a expansive charging infrastructure to support EV adoption across the country? Well, we modeled it down to the county. And, we see a huge build out in both public charging, around 300,000 charge plugs per year between now and 2050 need to be built. But China already has achieved that build out in just 2020 alone. So it can be done. And frankly, this infrastructure bill that was just passed, this bipartisan bill, which our very own Senator Romney had a role in helping with, it's going to invest, I believe, $7.5 billion in infrastructure for EV charging. And if we see a Build Back Better Act, additional funds will go in that direction. So we're on the right path. This is great news for us, for those of us who want to see cleaner cars and cleaner vehicles on the road. And of course, our huge trucking industry that runs our economy across our country also needs to be electrified. We need strategic charging ports, around 30,000 per year along major highways. But again, we've done big things before as a country. We have electrified the entire West in a big push, and we've built up transmission lines to connect regions and so on and so forth. We've done this, we can do it again. And best part about it is that if we accelerate EV sales and we get a clean grid, we will see 2 million net jobs in the year 2035. And that's driven by a combination of EV manufacturing, renewable energy build out, infrastructure, and some induced jobs because consumers have more savings in their pockets. They go out and spend it in the economy and it circulates. We took a look as well as what policies are needed to achieve the 2035 2.0 scenario. Now, I'm not going to go through them with you today because there were about 50 plus policy actions in our policy report. And they span core categories, including national and state vehicle standards, targeted incentives for both electric vehicles as well as charging, strategic charging infrastructure build out programs, which I mentioned, domestic manufacturing to bring more manufacturing onshore, and seize this moment in time where tons of countries are trying to be leaders in this space, and now is a ripe time for us to step up and lead. Smart rate design has more to do with, utility regulation and what kind of rate we charge when we're trying to plug in our vehicle. Do we have managed charging so that we have signals to the consumer that they may need, so that we don't have everyone plugging in all at once, so on and so forth. EV friendly codes and procedures speaks to the need for both local and state governments and builders and developers to accommodate new infrastructure and ensure that the permitting process and the interconnection process for new charging infrastructure is as smooth as possible and it doesn't get caught up in red tape. And then last but absolutely not least, all of these policies have to take into account equity and environmental justice. And what does that mean? That means making sure that the people who maybe can't afford a new EV still have access to perhaps a used EV with an incentive, or we are prioritizing development of charging infrastructure in places that are typically underserved, including rural communities and frontline communities that have been plagued by pollution due to transportation. There are a number of components to this that need to be taken into account. And I'm pleased to say that the Build Back Better Act, which has been introduced in now passed the House and now introduced in the Senate, takes into account a lot of these recommendations and reflects a lot of the equity and justice imperatives articulated in this report. First and foremost, though, at the end of the day, strong national and state vehicle standards are going to transform the market the quickest. They're really the tool that we have in our toolbox that can get us to a zero emission tailpipe standard in that 2030 to 2035 timeline. Already, there are states across the country, as shown in this graph, or excuse me, in this map, and these states have the authority through Clean Air Act Section 177 to adopt more ambitious or cleaner standards than the federal government currently has in place through EPA. California is the leader of this effort. They explicitly got a waiver to be able to do more ambitious standards because they needed to do so for their own pollution challenges. And there is an allowance in the Clean Air Act that allows other states to emulate what California does. Washington, for example, just adopted California's Advanced Clean Trucks rule, which is very exciting. So we're seeing some motion. Oh, and Nevada also just adopted the zero emission vehicle standard that California has. We're seeing some movement here, but obviously if we could see the federal government act and put in place strong standards that would affect all states, that's really the most efficient way to go about it. But it's up to the Environmental Protection Agency and Department of Transportation to pursue such rulemaking. So before I leave transportation, just a quick reminder that it may seem like when you look out and you see all the cars in the parking lot or on the road and they're all gas for the most part, like there's no way we're going to get there in 10 years or 15 years. That's just crazy. But when the Model T was introduced in 1908, the vast majority of transportation was provided by horse and buggy or bicycles. And some folks were really adamant about, cars shouldn't be on the road with the horses, and there were all sorts of conflicts with this transition. But within a 15 to 20 year time span, the car took over completely. And of course now is the dominant mode of transportation. So a similar time span, 15, 20 years, and huge transformation in how we move people and goods around. I'm confident that the electric vehicle movement is absolutely going to accelerate. And I think we're going to see a huge transition in our transportation space as a result. Okay, now moving to homes and buildings. And I think I'm clocking all right on my time.
Yep, you're doing great.
So, okay, great. So our homes and buildings, I think often get a little forgotten in the climate and clean air conversations. largely because we know transportation and industry are bigger polluters. We focus on the grid a lot, but candidly, that's changing very quickly. We're realizing that our homes and our buildings, especially with huge surges in construction, I mean, it's everywhere in Utah. I'm astounded how many buildings are going up and how many homes are going up. And like, we are one of those fast growing states that's seeing it before our very eyes. And every one of those buildings and homes is either an opportunity to go in the right direction or a lost opportunity. And right now, across the country, I think last year, we did about 1.4 million new homes, and about half of those were built with new gas infrastructure to serve heating load. And that's candidly the wrong direction to be going. We need to be building all electric, very efficient homes, and we need to be sure that they are ready for this electrified movement on the horizon. And this graph sort of confirms that we're doing really well in bringing down our electric power emissions. This is carbon dioxide emissions from the electric power sector from 2007 to 2019. So we've seen about a third decrease since 2007, which is awesome. But in our buildings, we're seeing an increase, and it's up about 7% since 2007. Now, part of that's because we've got bigger buildings, we've got more energy use, but we also have more gas going in. So this is a trend we absolutely need to reverse very quickly to get back on track. Now, some of you may have heard and or seen in the news that there is a projection of pretty severe price spikes coming down the pike for homes that heat with natural gas, propane, or heating oil. On average, natural gas bills are expected to be about 30% higher than last winter, and it varies depending on which region you're in. The West is a little bit more insulated, but we're still expected to see an increase. The Northeast is, a lot of the Northeast is propane and heating oil, so they're expecting an even greater spike, and it kind of depends on the winter. But in the next few months, we're going to really start to feel the impact of volatility in our pocketbooks. We see it a lot at the gas pump, but when it comes to our homes, this is gonna really put a lot of burden on a lot of people, especially those who are already struggling to pay bills and people who are saving for just to be able to pay their rent or energy bills or food. So we've got to do some quick fixes to make sure that the most underserved and vulnerable populations are not hardest hit by this forthcoming price spike. But there are only so many band-aids you can put on a gaping wound. At the end of the day, we've got to get these folks off of fossil fuels and onto clean, affordable electricity. A great group called Rewiring America did a very comprehensive analysis of what it would look like if we electrified all homes in the United States. And they found that at least 85% of the homes could save total $37.3 billion on energy bills by switching from fossil fuel furnaces and water heaters to electric alternatives. And those are heat pumps. I'll talk about that in just a second. And the average household would save around $356 on their energy bills. Plus, it would create nearly 500,000 installation jobs that can't be automated or offshored. So it's a job creation mechanism as well as a household savings mechanism. And the differences that you're seeing here on the map have to do with which places pay higher for electricity, which places have lower rates for gas and propane and heating oil, et cetera. But Utah looks pretty good. So, and that is largely due to the fact that we do have pretty affordable electricity rates. So as I mentioned, what are these electric alternatives? They're energy efficient, all electric technologies like heat pump water heaters and heat pump furnaces and air conditioners. Heat pumps are basically a transfer of heat rather than creating heat. And so I'm not an engineer, so I'm not going to endeavor to explain this, but effectively, because it's not creating heat, there's no lost heat, and it's 3 to 4 times more efficient than conventional heaters, especially when you're talking about water heating. It pulls warm air from the air, whether it's warm or cool, and then transfers it into whatever you need, whether it's cool air in the summer, hot air in the winter, or hot water year round. The other cool thing about heat pumps is that they are effectively a hybrid solution for heating and cooling. Instead of having to buy a new furnace or a new air conditioner, you buy one thing and it does it all. And induction cooktops shown here, these are not your average electric stove. These are way cooler. As I said, I cook with one, and they're very fast, they're very efficient, they're very accurate. They don't get hot, so if you have children in the house, you don't have to worry about your kid burning their hand. It doesn't emit anything in the air, and they're available today. In fact, I think this was an IKEA one for like $600, and it's just the cooktop. So moving from where we are today in our building sector is harder. I will say that. I think it's harder than transportation. The reason is there are a lot more entities that touch buildings than the transportation sector. So you have energy codes, which are written by voluntary energy code authors, and they convene, they do this every 3 years, they update the code, and then states have to adopt that code, or if they don't adopt that code, they have to adopt some code. And then local governments often have the ability to have their own code. And then there's, permitting and inspections, and then the developers and the builders have to also build to the code. And then you have appliance standards, and you have you have a whole slew of things that have to happen and converge for this to take place. I'm pleased to say that the movement is happening. So it's not that we have not started. In fact, there are a ton of great organizations working on particularly improvements to our energy codes, which should really be aiming for decarbonization codes instead of like just energy codes. But also they've created an all electric voluntary code that's already available that can be adopted and layered on. EPA has in its authority to adopt more rigorous appliance standards so that all the appliances have to be as efficient as a basically a non-fossil option. And that will help the manufacturers and the providers of appliance services get the message that we're phasing out gas appliances and moving to all electric options. Governments can lead by example in their own facilities. Several examples of that are already happening across the country. Utilities can offer all electric home incentive programs. There's some great examples of utilities all over the country doing this. Grants and technical assistance for contractor training and education and workforce reformatting, I think, is going to be key to ensuring that the guys who go and sell the HVAC system or sell the hot water heater, know about heat pumps, can give you the specs, have one on hand, and know how to install it. And then a consumer safety warning and regulation of gas stoves is probably not a bad idea given what we know about how dirty they are. The targets that we're aiming for are 100% all electric new buildings and appliances by the year 2030, and 100% of all buildings and appliances being all electric by the year 2050. So that's retrofits and new. So again, our new construction is really a ripe opportunity to seize the moment and transition from stranded assets to all electric efficient assets. State and local, as I mentioned, there are a lot of synergies between the national and federal tools, but there are a lot of things that state and local governments can do on their own without a federal government or a national code entity. We're seeing a huge movement among local governments adopting all electric codes or outright banning gas in new construction, and that's driving a lot of change in the markets. Several are setting their own decarbonization targets or offering incentive programs for electrification or distributed generation. Utilities can start planning more proactively for electrification, both electric and gas utilities. Some are exploring a fee-bate on fossil fuel appliances, so basically a small surcharge on appliances that then goes into a fund that can fund electric appliance incentive programs. A revolving loan fund for financing for building retrofits would go a long way in helping to overcome that cost barrier that a lot of folks face. And then, of course, setting these goals for state and municipal buildings to become leaders in decarbonized buildings. So what all of this means for you, I think it's going to depend. It's going to depend on, where you live, what your financial situation, what you're able to do today versus in 5 years. But the thing that I always try to remind people is like, don't get overwhelmed with how difficult the problem is. Start small and start where you can. Your dollars are your biggest tool in this fight. And to the extent you're able to in climate, including clean air technologies where you live, whether it's your car or your home, or even the products you buy, that goes a long way, and never discount it. In fact, we're seeing huge movements by corporate entities in response to consumer demand for better products that are not going to, burn our world up. So it is a real thing that our dollars drive change. If you rent, have a conversation with your landlord about the options. I was a landlord for several years, and anytime my renter came up with like, hey, can I do this improvement, or can I invest in this, or would you split the cost with me? I was pretty reasonable, and if it made sense, then I was always willing to explore the option. So consider that, and especially coming up against a winter that might be really cold, weatherization, energy efficiency measures go a long way in saving energy. So definitely do those first. Start tracking how much energy you're using in your life and make adjustments. See, if you turn down your thermostat 2 degrees, what does that do to your energy bill? I know these sound like simple things, but honestly, they do all add up. And if every one of us were doing it, we'd have a much easier way forward. I've done something new that I'm kind of excited about. I've started a clean energy savings account. So, we all have savings accounts for like vacations or for like new stuff that we want to get. And now I have one for stuff that I would like to be able to purchase for my home, including a new electric heat pump water heater for when my electric water heater goes out, which is probably going to be, when my gas water heater goes out, which is probably going to be probably this year because it's very old. So by setting aside funds for this, it won't come as a sticker shock when you have to make that investment unexpectedly, but also you're kind of planning for what comes next, especially with appliances that last 10 to 15 years. It may not make sense to replace them right away, but maybe in 5 years' time that does. Talk with your family and friends about climate and air pollution and solutions. I know this sounds a little Pollyanna, but we are not having very good discourse in our country around a lot of topics. And often people avoid this topic because it can be perceived as contentious. But we need more people to understand that this is real, this is happening, this is affecting our health and our future. Have a discussion, don't argue. Reach out to your local and state policymakers. They should hear from you as often as possible, especially if you have solutions and ideas. And many of our local folks are very responsive. So don't be too shy. They're everyday people. Start a community or local or school campaign, connect with nonprofits, pursue grant money, start where you can. Getting engaged in politics is always an option. But if you're not that inclined to go down that route, just make sure you vote. Inquire with your utility about various incentive programs, and get a job in the clean energy and climate field. We are hiring. There are so many jobs, and my LinkedIn profile is where I post a lot of jobs. So feel free to connect with me there and track my posts. But trust me when I say that the green job movement is happening, and it's only going to get bigger. As Ben mentioned, I do have a podcast. Would love for more listeners and subscribers. And if you do like what you hear, give us a positive review and a 5-star rating. It helps with our search profile on the internet. And with that, thank you so much. I think we have about 15 minutes for questions.
Thank you so much, Sarah. That was fabulous. For those of you who, we have actually a bunch of questions. It looks like about 15 questions on that Slido. So remember, if you want to go and rank those, take just a minute now, then we'll make sure we address the ones that they float up to the top, depending on how many people voted for them. So the first question here on Slido is, what steps are being taken now to transition Utah to electric infrastructure?
That is a great question. So I think not enough, if I'm honest. Utah has some challenges with a couple of things. The first is I believe there's a state prohibition on fuel switching, which means that like if Rocky Mountain Power wanted to offer an incentive for an all-electric heat pump, which they do, it can only be applied if you're replacing an electric resistance furnace or water heater, which basically means it's not really helpful to folks who have gas. So changes to policies like that would be hugely helpful. And I know that Utah Clean Energy has recently hired an electrification person who's targeting these efforts, both state policy as well as local. I know that Salt Lake City's looking into this more and more. Honestly, with the pandemic and with a lot of major challenges, I do think the last year was like kind of a lost year for a lot of other things in Utah, but I'm hopeful that going forward that we're elevating the level of interest in both the local and state politics, as well as our federal folks. As I mentioned, Mitt Romney was a big part of the infrastructure bipartisan deal, and he helped ensure there were EV charging incentives and programs. So that will absolutely help benefit Utah. So more needs to be done. That's the answer.
Thank you, Sarah. This next question comes up really often in discussions of renewable transitions, and it's with a greener grid and major electrification. What solutions do we have for processing dead and dying solar panels and batteries? How do we set up our system now to reduce the environmental impact of this transition? And I'd recommend anybody who's interested in diving into the details, check out Danny Kennedy's lecture from a few weeks ago. He addressed this really directly. And I don't mean to take your spotlight, Sarah, but the first message is you have about a 99% decrease in the amount of waste that's generated. So let's not, we of course should be thinking ahead, but we also need to acknowledge it's much cleaner, even if we do it the worst possible way. But over to you, Sarah.
No, I mean, you covered a key point there, Ben. And the other thing I would just add is I know that a lot of manufacturers of EVs and batteries are beginning to explore recycling programs and refurbishing programs, simply because it's expensive to extract new resources and build new things. So if they can recycle and refurbish, they have a new product, and they also have a new source for their the components that they need. And I would expect too that used EVs in particular are going to be more and more available as people who like to buy new cars and want to go down that route. They sell their old car and then they circulate in the economy. Just the other day, I was looking on KSL out of curiosity. You can get a used Nissan Leaf for $8,000. So that to me is like the most environmental choice you can make, and it's not that expensive. And I will say that the Build Back Better Act, I know I keep mentioning this, but it's a huge climate policy. It's a huge opportunity for us to really move in the right direction. Does include currently an offer for an incentive for used EVs. So that would unlock the market even more. And solar panels last 25, 30 years. We haven't really reached the terminus of most life of those solar panels. I am hopeful that the industry will take responsibility and move in the right direction and not just scrap all that product. I think it's far too valuable.
Thank you so much. And those of you who've put questions in the chat, please shift those over to Slido, and then we'll get to them if we have time. But there is one here directly to me. What are the major threats that could really slow this transition? There's lots of market forces and technological advances. What are you worried about looking forward to the next 10 years?
Oh boy. I think I'm most concerned about the incumbent fossil fuel entities just doubling down and resisting this transition for the next 10 years and putting us further and further behind our need to move quickly, which to my mind as a business opportunity, it makes sense to begin transitioning now. If you see the writing on the wall that your life is coming to like an end, then what a great time to begin to diversify your business portfolio. There are actually things happening in that space. Several oil and gas industries have begun to, at the request of investors and shareholders begin to diversify their businesses to shift away from solely oil and gas. The other big threat that I see, and it's definitely the elephant in the room, Russia and China are still, and India are still huge consumers of gas and coal. And they need to move very quickly, leapfrogging our industrial revolution and move into the clean energy revolution for their growth on the horizon. I can attest from work that's being done in my organization, a lot of folks are helping them with that, mostly China and India. Russia is a little bit more recalcitrant.
Thank you so much, Sarah. I'm just recognizing the time. If anybody has to leave to go to their next class, feel free. It's not rude to stand up. The next question is, you addressed this some at the end of your presentation, but for people who aren't professionally involved in energy and climate, what are the most effective things they can do to advance these causes?
Yeah, great question. I mean, so many of these decisions that I talked about happen around the kitchen table. You know, whether it's with your significant other or your husband or wife or your mom, your dad, talking about, you know, which technologies you're going to buy next, what's happening in your home. That's the best place to start. Getting involved locally, getting involved with politics, getting involved with processes that affect where you live, also a very wise way to move forward. And, you know, we forget that democracy is a participatory sport. It is not something you sit on the sidelines and watch happen. And there are so many great local leaders who want good ideas and they want to know what their constituents want to see. So bringing forward to your local leaders ideas about how to make things better where you are is such a great way to get that conversation started. The change may not happen immediately, but trust me, you can be persistent, you can be persuasive, and over time, things will change. I think I helped pass close to a dozen clean energy bills during the time that I was with Utah Clean Energy, and you know, who am I? I'm nobody. I'm no fancy legislator.
Thank you, Sarah. The next question, it takes a different turn. Thinking about the avoided deaths associated with our current dirty energy system and the transition, this really seems like a moral issue. Why aren't we talking more about the ethical implications of our energy choices?
What a fantastic question. I don't know the answer, but my response is that we have really become ingrained, our economy has adapted to accepting externalities as part of how we do business. So that means somebody else is going to pay for that. It's not my problem. And it's really part of how sadly, our capitalist system is set up, only because we don't put a price tag on the loss of life or the premature death or the pollution that's being emitted by industries that really don't have to pay for those costs. So, you know, shifting from an economic standpoint to begin to price those things and incorporate them into the price of products could be one approach. But as you point out, as the person who asked the question points out, having that conversation more, particularly with spiritual leaders, religious leaders, people who are empowered to help elevate this in kind of the moral context, I think is super important, and would love to see more of that.
Thank you so much. This next question, which I think will be the last one before we take a little break, is how important is carbon sequestration technology to reduce CO2 currently in the atmosphere? And should we prioritize both CO2 sequestration and renewable energy, or just one?
Another great question. So carbon capture and sequestration does have a role to play in achieving the last 10 to 20% of our clean grid scenario. So by the 100% 2050 timeline, that's where I think we're going to be really needing to rely more on a subset of applications for carbon capture and sequestration. Biggest challenge with carbon capture and sequestration today is that it is very expensive relative to the alternatives. It is also not exactly a proven technology. We don't have a great solution as to where are we storing this, and we don't quite know what happens when we do. So more research and development absolutely needs to happen in this space. so that we're prepared when we need to like kind of double down there. The other application for carbon capture and sequestration on a smaller scale, which is very important and something that should be prioritized, is for certain industrial applications that are harder to electrify or decarbonize otherwise. So I can attest the Department of Energy has a ton going in this direction. I think the new infrastructure bill included some funding to go in that space, as does the Build Back Better Act. So I'm anticipating that there will be more focus and research and development on that, but it's absolutely not an either or. We need a lot of renewable energy regardless. So that needs to be concurrent with any CCS application.
Thank you so much, Sarah. This has been a real pleasure, and you've kept us all in rapt attention. Just want to announce before we thank her one last time, we are going to reconvene in about 5 minutes in 5001, the beautiful Dean Suite up on the 5th floor. If you want to have a more informal conversation about professional development and detailed questions with Sarah. But let's give her a big round of applause for taking the time.
Warming with her melting ground, fruitless hunting, swimming round and round, dissolution of your home, of all you've loved and all that you've known, and you are starving and we are watching and we